If you find these videos helpful, please consider supporting Ad-Ohms and the Bald Engineer on Patreon. Hi, my name is James and I'm the Bald Engineer. Welcome to an Ad-Ohms live stream. That was actually a little bit unexpected. I meant to right click on something and oops, it started. So if this is your first time here, I am multi-streaming, which means I am streaming from Twitch, YouTube, and Facebook. The cool thing is, wherever you are, wherever you chat, it will end up showing up somewhere on the screen, so I will see it. In this live stream, it's going to be a working live stream. I picked up something super cool, which was this kit from Evil Mad Scientist Laboratories. It is a discrete 555 timer made with surface mount components. So we're going to solder this together in this stream. Now, just as a comparison, I have this one, which I put together about 4 years ago. This was a through-hole version of the 555, which is actually pretty cool. It works. I did a write-up on that and stuff like that. So we'll be working with the surface mount version today. If you're interested in the kit, you can pick one up from EMSL. They're about 30 bucks, and there is both the 555 as well as, let's see, oh, I already loaded the wrong page, as well as a 741, which is the super common or popular op amp. I do have both, but I only plan to work on the 555 tonight. Okay, so let me say hi to people in chat. Hi, Tim. Hi, Paul. Paul's a proud owner of the 3.5s. Yeah, that is it's one of my favorite kits. And so, yeah, okay. Let's get going because I want to see what this thing looks like. So I've already opened it up, but the directions are nice, clear, easy to read. If you've never soldered before, looks like they kind of step you through how to do surface mount soldering without any kind of special tools. I'm going to be doing a mix. I'm going to do a little bit with my soldering iron, and then I want to do most of this with hot air because it's a little bit easier to work with. So we'll give both of those methods a shot. So if you're not familiar with either. One thing I did want to point out is I thought this was really clever. So this whole kit is to be a surface mount kit, right? And when you buy surface mount parts, they come in a carrier tape. And so Evil Mad Scientist actually, they put all of the parts into carrier tape. So it's just kind of a clever meta joke about you get a carrier tape verse full of parts, which are coincidentally also in carrier tape. So that's pretty cool. So I'll put that up there. And then that's the mechanical part. We don't need that till later on. I don't know what, oh, these are probably the nuts. We'll work with those. Some more hardware. Okay. Hey everyone. Yeah, this thing is, I don't know of a better word to describe it other than it is super cute. Let's try to do this. So here's the actual board we're going to be soldering onto. I mean, the design of the board is absolutely gorgeous. I always get his, okay, so the person that actually designed this, he also did the 3.5s. His name is Eric Schlepfer. I really hope I said his name correct. I realized today I've never actually said it out loud. You can actually find him on Twitter as TubeTimeUS. He does a lot of really cool things, including the Monster 6502, which is a massive discrete 6502 replica. But he designed this one, and I think he did an amazing job. These things are just gorgeous. I almost wish I bought a second one so that I don't have to actually solder to this one because I just like the board. The board looks like Osh Park After Dark. Oh, I totally meant to ask if that was the case, and I forgot because I thought the same thing. Okay, let's see. What do we need? Let's grab this guy. We'll use this to hold the board. Let's just get this into here. And then let's it's going to be easiest for me actually. I'm going to move this around, and then I'll make sure you guys can see it on the camera. Get this up to here. All right, and then I'm going to tell the camera, make sure you stay focused over here. And I'll probably zoom in a little bit. For now, I just want to see how this is going to work out. And then I'm going to start with a regular soldering iron. So let's get that going. This is connected to number 3, WX65, 3 on. Oh yeah, okay. Now, what am I going to do? How am I going to do the parts? So I think what we're going to do, the way I understand it, is you basically just go down the line. And so what I want to do is take some double-sided tape, get rid of the trash, and we're just going to kind of try to tape this carrier tape down. Tape this carrier tape down. This is so cute. I just think it's clever that they did it this way. All right. Hey Wesley, I see you checking in. Hope things are going well for you. Man, it must be like 2 o'clock in the morning for you. Let's do that. All right. Let's see. This is, do I want this tip? I'm going to start out with this tip. It's a little bit bigger than I would really like, but I think that's going to be okay. So now let's get, let's do this. Try to reduce the bouncing a little bit. Okay, lock. Okay. Now, if you're afraid of surface mount components, first I would say I think soldering surface mount, even without exotic tools like a hot air station, is actually easier than through hole. One of the reasons is because I never have to flip this board over. I can do everything on one side. You don't have to move things. It's easy to see what you're doing. You are dealing with smaller components, and yeah, that's going to be a little bit of a challenge for some people. But like in the case of this kit, these are all 1206. All of the passive components are 1206, which is a really easy piece to solder. I think if you can solder leads on a component, you can probably solder 1206 without too much trouble. Okay. So what I'm going to do, I'm dump those out, and then the time-honored trick of picking up and dropping them. Nope. Oh, it's not working because it's actually not bound. If this was, since this is silicone, it's they're not bouncing. Okay. So according to our directions, R1 is a, let's see. So the long directions say use R1, but I'm just going to go by, this is part number 2, and then these are the locations we're going to solder to. That carrier tape is pretty awesome. Great idea on their part. Yeah, this was, I thought this was super cute. I mean, and what I was really curious when I first read about the kit was I wondered how were they going to package the components in a easy to, an easy to handle manner. And so I thought that this is a really clever way to do it. And like I said, it's kind of meta, right? When you buy surface mount parts, they come in carrier tape anyway. All right, so R1 is, of course, all the way on that edge. So we're going to, oh, you know what I want to do? One more thing. Hold on just a second. Okay, I want to clean the board with some alcohol, IPA, not the beer type, but the cleaning type, which I was actually really excited. The other day I found at my supermarket store, they have 99% IPA. And so that was really exciting because a lot of times it's like 70%. and that and that's just not good enough. All right. Hi, Cola, 7:35 a.m. Good morning. We're going to do some soldering. All right. Let's get some tinning going. I did realize right before I started, I have a really great solder ventilation system, and I am not at all set up to use it while I'm on camera. So I do recommend that you use a ventilation option of some type. So don't do as I do, do as I say. Okay, it's in place. Let's try and go a little bit closer. Okay, cool. One down, a bunch more to go. I need a pen. Can I borrow a pen from somebody? Uh-oh, uh-oh. Where did my pens go? Okay, this works. Medical supply shops can get good deals on 4-liter jugs. Nice. I had not thought about that. Can we get an extreme close-up of the board? Oops. That's actually not what you meant, but hold on. Come on, snap back. That's as much close-up as I can get for the moment. Yeah, that's the best I can do. Okay, so R1, now R3. Looks like it's right there. We'll do dab of solder. Actually, I'm going to do these now. 7, 8, and 9. So 7, 8, 9. 7, 8, 9, 11, and 15. There's 17, 13, 15. And did I say 17 or 11? Okay, 15 and 11. Okay, there we go. Now that will allow me to have my hands in the right orientation. Let's, I can move this over a little bit. Oh, this is good. This way people can criticize my soldering, which I want to point out, I almost never surface mount solder this way anymore. Just FYI. I almost always use my oven or hot air, which we'll do later, because hot air is cool. Oh, wow, I just realized what I said. That was really bad. Hot air is cool. So I'm just getting the pad, I'm heating the pad back up, and then I'm sliding the resistor in, and I'm trying to give the solder just a second to heat up and adhere to or wick into the terminal of the resistor. After I tack the other side, I'll come back and hit them again just to make sure that solder is reflowing all the way. Right now, all I'm trying to accomplish is getting half the resistor to stick onto the pad. And one thing I am trying to avoid, even though these are resistors and they would be fine if I did it, I try really hard not to hit the terminal with the soldering iron because resistors are not really a big deal. However, capacitors, like a 1206 ceramic capacitor, you could actually damage, which like I would have done just now. doesn't happen often, but it's a possibility. That one's a terrible joint. That's number 8. Yeah, I'll have to come back to that. So we'll get this one onto here. Oh, terrible. Absolutely terrible. Okay, that's better. Mezzantine on Twitch. How do you keep the solder from pulling away with the iron? I always struggle with that. A lot of practice. Yeah, so if when you pull the iron away, if the solder's following with it, there's a couple of things that are happening. One, I'm going to bet you need to clean the soldering tip a lot better because it's not allowing heat to flow very well. The other thing that might suggest is you have too much heat on the soldering iron, because what you would sort of, in an ideal way that I think of this, is when you hit the iron onto the solder joint and the piece of work, or in this case like a resistor, you sort of want the iron to cool down a little bit as it transfers the heat away. And so if the iron's too hot, there's not going to be enough of a thermal transfer, and so it's just going to pull the solder along with it. I don't know if that makes sense, but my guess would be you need to clean the tip of your iron and the heat is too high. Okay. But of course, I just realized too, that's like what people always say when it comes to soldering is you're clean your tip and use less heat. It's like the universal recommendation. All right, so 1 should be done. 3 we'll do next. So I did ask the evil mad scientists themselves if they were going to provide a stencil, since this is an entirely surface mount version, because like I said, I would prefer to use my soldering iron, my oven, which you can see up in the corner of the main view. And they made an interesting discovery, and that is it's really difficult to buy stencils in volume because they're not really a volume purchase. People generally they buy one stencil or maybe like 2 stencils, and so whether they buy 1 or 100, the price is the same. I really don't like that one. Let's see if we can fix that. So my thinking is I'm going to, like I said, for purposes of video, I wanted to do regular soldering, then hot air on this one. And when I do the 741, I would really like to do that one with my reflow oven, just so that I get one that looks really nice. All right, so that's done, that's done. I think we're just going to go with what we got. This is looking pretty good. Okay. When in doubt, clean your soldering iron tips. Okay, now I'm really nervous. Hi, Eric. How you doing? Okay. It comes a reflex after a while. Yeah, actually. You know, actually, I mean, soldering is to me, it's such a strange skill because I've actually had a lot of people ask if I would do solder instruction videos or how-to videos on soldering. And I did that series of soldering videos for Element 14, which is probably going to be as close as I get to a soldering tutorial. And the reason is I'm just really not that good at soldering. First, I don't have the best technique, so I don't really feel comfortable teaching. But I also have been doing it for so long, I don't think about what I'm doing. And so like even now, it's sort of hard for me to describe what I'm doing because I've gotten used to it. And so actually now that I've said all that, it's probably a good reason to do a series on it, but that's okay. So Eric, since you're here, I just wanted to say, I was not ready for how cute or adorable these boards are. When I opened it up, I was like, oh my God, it is so small. It is so cute. Yeah, you did a fantastic job with these, man. All right. So this is going to be 820 ohm resistor for what was it going to be? R2. Oh, come on. Okay, so I'm having trouble separating the tape. Let's see if this trick works. Can you see what I did? Yeah, probably not. It's out of focus, so I'll explain. So I just took a double-sided piece of tape. I taped the carrier tape down, and then I use my tweezers to open it up. It works a lot better most of the time. I love it. Thank you so much. Yeah, you're very welcome. When I saw these get posted yesterday, I was super excited to get a hold of one. So I ran over to the store this afternoon and picked it up as soon as I could. Okay, R2 is anti-aware. That's a good name. So R2 is here. All right, let's do that. Sat for too long. Regarding the soldering videos I mentioned, if you head over to baldengineer.com, you'll find links to all of the Element 14 stuff that I do, including the series on soldering. It did bother a few people that it was sponsored by a particular vendor, but I tried really hard to make the content interesting or useful and not just not just an advertisement for the hardware. Although, obviously, it won't take long to figure out who the sponsor was. All right, let's get this guy in here. Oh, come on. Okay. Come on. Okay. Not as straight as I would like, but I'll take it. So I just read this article the other day that Vishay, who they make a lot of stuff, a lot of passive components, as well as I missed one. They make as well as semiconductors like MOSFETs, but apparently they've decided to stop printing the resistor values on their surface mount components. So that's going to be interesting. Let's see, first time watching something live. Sadly, it's 3:20 in Denmark. Yeah, sorry. I will be doing, I do plan to do a couple of live streams this week. It's a holiday week for me. I decided to take a couple days off of work. And there's two more topics I want to stream. One for sure, and the other if I have time. And I'm going to try to do them at different times just to try to accommodate the rest of the world. And then the comment on fume extractor is, yeah, I sort of ran out of space. I've got one. I just don't have a good place to put it. So when I film, I can't record and have the thing going. Also, it's super loud, so you wouldn't be able to hear anything I say, which might actually improve the quality of the stream. All right, so R4 is a 1K resistor. So let's do this. Put that down there. That is right where you guys can't see it. Let's try here. Still can't see that. Let's try this. So I got my double-sided tape. Smash down the carrier. Peel it back. Come on. And this time it gives me trouble. All right. It's free. Really? Okay. That's nice. Okay. So this is going to be R4. It's a 1K. Anyway, what I was saying, I feel like I'm all over the place. What I was saying is that Vishay is no longer printing their values onto the resistors, which from a manufacturing perspective, I guess makes sense. I mean, it doesn't really matter. But from a hobbyist prototyping or repair perspective, that's a real pain, because now it's going to be harder to identify something just by looking at it. I mean, if it's a 1K resistor, it's pretty obvious it's probably a pull-up or something. But if it's like a funny value, like 23 ohms, then you know it's something critical. Of course, my hand moved. Come on. Okay, that actually went down really well. Get this guy. Also, regarding the fume extractor, I've been soldering for 25 years now at this point. One more night of it is not going to do any more damage than it already has. Flip the board upside down. Okay. Yeah, kind of sad about those resistors. Most surface mount capacitors don't have values either. Yeah, all the ceramics don't. Although the capacitor company I worked at, we had an option where we would laser etch the values onto the capacitor, but it turned literally 0.01 cent capacitors into 10-cent capacitors. There were very few customers willing to pay for that. All right. I think what I need to do at this point, because this tape is getting in my way, let's just cut it where we're at. All right. This is the R5 10K resistor. All right. Or focus only on the board. It's too far to see. Sorry. Yeah, it's zoomed in as far as I can go, and I mean, for me, it looks like it's in focus. Maybe bump up your stream a little bit. Actually, let me double check. Yeah, should be. Yeah, still going at full speed. All right. R5 10K. Where's R5 at? All right, down there, near ground. Okay, and then let's bring this around this way. Ow, 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 ow. I did not poke myself, although I did. Okay. There we go. I was saying in the, so I do have an Atoms Discord. There should be a link in the description, both on YouTube and on Twitch. I don't think there's one on Facebook. But I was saying before we got started, I did a fantastic job of planning this stream right at the moment that I was going to be hungry. So any mistakes we're going to blame on me skipping dinner. There we go. Doctor, that hurts when I do that. Yeah, I shouldn't do that. All right, let's come into here. I don't like this one. It's not, don't like that joint. Okay. What do we have? Up until we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay. I would really like to not use the iron anymore. So, but I'm going to do the resistors by hand, and then we'll do the transistors by hot air. I'd like to do these, but it's not going to be worth setting it up. With various values, I'm worried about if I get my air set up wrong and it blows them off. I don't want to go finding them. All right, turn that over, turn that over. So this is 100K, and it's going to go to R6. There's that one, and R17, which I remember over there. So we'll do it this way. We'll get R6 done first, because then I need to reposition the board for 17. R6. Oh, there we go. Bring this back over here. Okay. Now we will flip this around because I got to get over to this side. There we go. Get a dab going on this guy. That is there. Come over to here. And then get this pad into place. Come on, get on there. Nope. All right. Sorry about that. Usually I try to mute, but I'm trying to make some progress here. There we go. I might end up going and wicking all of them, just to make it look nicer, but yeah, anyway. 6, 7, now let's get to number 10. So number R7, or number 7 is R10. And we will get this going. All right. Okay. So, question for everybody in chat. What has been something you built with a 555 timer? It could be as simple as making a blinky, and it could be complicated like whatever Wesley says. All right, so this is going to go to R10, which is up here. Okay, that doesn't smell right. Get this guy going. Come on. Uh-oh. That's not going to be good. Nope. Saw that coming. Let's try this again. Wonder what happened. Get this going into here. That's good. Atari Punk. Okay, so I would like more details on all of these. An ADD converter, like how does that work out? Atari Punk console that has all the words that I like in it, and then an overkill switch debounce. I love the idea of using a 555 to debounce a switch. It's sort of like using an AT Tiny to flash an LED. It's just you don't need to do that. All right, so these are a couple of nasty joints. So let's do a little bit of cleanup and say, okay, yep, that's better. That's better. And then maybe come back and touch to here. That's going to be better. Okay. All right, that's much better. Blame Ben Eater, it was his idea. Yeah, actually, he's got a fantastic kit that I would like to pick up, which is his 555 clock kit. I mean, he's got a lot of other cool ones, but like from a practical perspective, I think the clock generator that you can build would actually be something useful to have. Well, that sounds really condescending. I just meant if you wanted something, never mind. All of his stuff is cool. I highly recommend buying any of his kits. I'll just leave it at that. All right, number 8 is R12, and it's a 6.8K resistor. Yeah, this is actually going a lot easier than I thought it was going to. This carrier tape idea is really making this so much simpler because you don't have to even sort the parts out. Everything's just ready to go. All right, let's put this in the middle. Uh-oh. Looks like I got flux on my tips. Where did my alcohol go? So I noticed on my tweezers, when parts start sticking, it's usually because there's flux on the tip. Ben Eater's great. I met him at VCF West. Oh, I'm so jealous. I wanted to go so bad. I had like 2 other things that weekend though. Yeah, he seems like a super nice guy, really sharp. I think the last thing I saw from him was the VGA, discrete VGA board. He's probably done other things, but that was the last thing that caught my attention. R10. Where did R... You would think by now I would be running out of... So that's 12, 13, 14, 16. Uh-oh. Q10. I already did that one. I'm on R12 now. All right then. That's how that's going to go, huh? Awesome. I didn't think a 555 made from discrete components would actually work. Just want to point out, so also from Eric was the original 3.5s, which is from through-hole components. And I actually think on my website, I've got screenshots showing this versus a real 555 timer. And I mean, it works. There's a little bit of an offset, or was it an offset? Or the signal wise, it's a little bit different, but functionally, yeah, it works. And I've already got a 555 circuit set up, so no promises. If I don't screw up, we might actually get to see this one work tonight in an actual counter circuit. Okay. Let me get, oh, come on. Get this. Come on, guys. get into place. And done. Don't like that at all. It's not flat. Now it's not straight. Oh, bad timing on my part. Okay. Yeah, that was terrible. Absolutely terrible. All right, much better. Mucho improvo. Get that guy a Snickers bar. Yeah, that's... One of my intentions was I didn't want to eat so that I would work a little bit faster. I did not think that plan through very well. This totally reminds me of the time, and this was back in the PlayStation 2 era. I'd only been out of school for a couple of years, maybe like 2 years, and my friend, who was my roommate one summer, had just gotten a PS2, and he wanted a mod chip installed. And so he ordered the mod chip and told me, yeah, it's got like 20 wire connections. I'm like, don't worry about it. It'll take me like half an hour to do it. Well, it took us about 6 hours to actually get that done because the instructions weren't for his version of the PS2, and it took us a couple of hours to realize that I had done like 6 or 7 of the connections, and I got to number 9, and the solder point wasn't anywhere to be found. And so what was supposed to be like a 1-hour job ended up being 6 hours. And I think I skipped lunch and dinner that night. That was a really bad day, but we got it working. So that was a good lesson in estimating how long a project will take. Okay, this is number 9, 3.9K, is it? Yep. And it's going to go to R13. That's right on the edge. Kind of do one of these. Astable, driving monostable. Okay. Overkill, make sure that the target stays down. Sarlacc, oh man, I just missed your message. So you use a 555 for 10 years, and I think I saw Pulse Driver, and then I lost it. But I will look at that later. One thing I don't want to usually do is touch my keyboard after I have lead solder. Because I never eat while I work. That would be terrible. All right, I'll start do at least one transistor with an iron. Fair enough, okay. So we'll start a debate. Right now, I'm using let's see if I can get in here, a brass sponge to clean my soldering tip. Do you prefer a brass sponge or a wet sponge, and why? And I've already done a video on the right answer. All right, so that's in there. Are you using 60/40? Yes. What gauge? I have no idea. I don't know what it is in real units, but it's 0.02 inches. Okay, so 13's done. Now we're down to 14, which should be number 10. I'm a wet sponge guy, mostly out of habit. Okay, yeah, I think that's a fair reason. Like I was saying a little bit ago, a lot of times, soldering just comes down to, it's sort of an art and it's practice, and it's how you get used to, it's what you get used to doing. One of the reasons I bring it up is, let's see, before I say this, wet because I'm too impatient to wait for tip cleaner in the mail. Ooh, I got something for you. Let's see. Brass seems to do a better job getting burnt, and same thing about wet. So first of all, you should not use the tip cleaner stuff on a regular basis. So I don't want to implicate a brand name. So if you've got this stuff, which looks like, see, I don't know if this is going to open up. Let me get a brand new one. I just realized there was solder or something that fell on the side. Yeah, so you get this stuff. You should only use this on an occasion. So if your iron gets really dirty, or maybe if you're soldering on a regular basis, like once a month, or as a point of maintenance, then you can use tip cleaner. This stuff does erode the chrome plating of the soldering iron tip. So be careful with it. Do not use it every single time you solder, because it does literally wear down the tip. That said, one of the reasons I asked the question was this, because there's a lot of people who believe that, ironically, the wet sponge is bad because it causes your tip to crack, and the brass sponge is bad because it causes your tip to scratch. And neither of those are entirely true. The brass sponge is probably the least damaging to a soldering tip. Just make a quick adjustment. However, it's not really any better or worse than the wet sponge. One downside of the wet sponge is it does rapidly change the temperature of your iron, and it does put water, which has oxygen, right in contact with the tip, and so it has the potential to oxidize your tip. However, one thing that I noted is for a lot of people that are new to soldering, because you tend to get a lot of crud and junk, and your tips just kind of, you don't maintain the tip as well. The wet sponge does a much better job at getting rid of really built up oxidation, ironically, since it adds water. But I think, personally, I do think it does come down to whatever works for you, use it. I like the brass sponge better, but I understand why people like the wet sponge. The real message I wanted to say is it's not entirely clear to me that there is a perfect answer. They both have some trade-offs, but they both work well enough. So, is the tip cleaner quite corrosive? Yes, it is very corrosive. In fact, that's its whole point, is it has a very aggressive flux so that it can properly clean the tip. And so that's why it's in the video I did on solder maintenance, I made a little bit of a joke and said it's weird that to maintain your tip, you should use the tip cleaner every so often, because it does help to break up and clean away really excessive oxidation. As oxidation builds up on your tip, it doesn't work as well, which causes more oxidation. So by cleaning it away, it helps. But by using too much of it, it literally does wear down the plating on the tip. So it can extend the life of your tip if you use it sparingly, but if you use it often, it will eat away at your tip. Now, if you don't care and you're fine with replacing your tips really quickly, then sure, go ahead and keep using it, but it will wear down your tip. That's the way it should, that's the way they work. It works. Anyway, enough of my soapbox. I already took it out. Number 14. R14. I feel like I saw that before. And I mean, I'm basically down to, I think there's only like 2 resistors left. So there's 16 and 14. Oh, I want to get that away from the solder. Now, actually, in the maintenance video that I did, which you can find at baldengineer.com, and I shouldn't say I did it because I did have help from 5 other of the hosts on Element 14 Presents. But basically the method I said was start with the brass sponge. If that doesn't work, then use the wet sponge. And if that doesn't work, then use the tip cleaner. And if that doesn't work, there's actually this cold polishing bar that you can use, which is basically the last resort. You may end up destroying your tip, but at that point, nothing else is going to work anyway, so it's worth it. But that polishing bar, you really shouldn't be using unless the wet sponge can't get whatever it is you're trying to get off, or the tip cleaner. Beautiful. But I think well-maintained soldering tip is just absolutely the #1 thing that people struggle with when they get started. Almost every soldering problem that you run into is because your tip is either not tinned well enough, or it's oxidized, or you have usually too much heat. It's kind of one of these amazing things. Once you sort of dial in using your iron properly, you'll be amazed at how much better or easy it is to solder things. I don't like that at all. I say that as I screw up the solder joint. Okay. I'm not making that any better. My hope is I'm getting kind of these bubbles of solder off of here, but I should have solder between the pad and the bottom of the component, so that way it still looks nice and it's connected. My parents just get angry that I'd wipe the soldering tip on my blue. Yeah, don't use... Actually, so Jay Kittle, 99, good joke. Yeah, denim will work really well to clean tips because it's like because the cotton will actually help to absorb some of the contaminants. But the problem is your denim contains dyes, and those dyes are actually going to contaminate the tip. So you really don't want to use that. You don't want to use something that can actually add back into the tip. So like I said, good joke, but don't do it. I believe flux solves most soldering problems. Robert, you are 100% correct. Usually, it's funny. I can sit here all day long and say, tin your tip properly, keep it clean, blah, blah, blah. You know what? Just put a bunch of flux on your board. It'll work a lot better. Now, it has the same problem as the tip tinner. Flux is aggressive, so you have to be careful from that perspective, but it solves a lot of problems. Okay, part number 11 is R16, which is the last resistor, which I think I was just looking at that one. It's right there. Beautiful. And then we get on to the transistors. I would dip the whole board in flux if I could. Yeah, no kidding. Yeah, the other thing to keep in mind, flux, or does it? Never mind. I'm not going to say that out loud. All right, let's bring this back around. And oh boy, last resistor. All right. Okay, this is really fun. And I'm definitely going to end up buying another one of these because I want a version of this board that's untouched. It's just too pretty. Okay. For those that have just joined recently, so this is the 555 SE. It's a discrete version of a 555 timer where it's all surface mount components that makes a functional 555 timer. It's available from Evil Mad Scientist Laboratories. And it is actually a follow-on to a through-hole version, which was called the 3.5s. And so I actually built this one about 4 years ago, and it works. And so this is a functional 5.55 once we get all the parts on. All right, so what I'm going to do at this point, I just want to clean up some of these solder joints because they're kind of nasty and it bugs me. So let's just take some wick and, oh, then you can't see it. And I'm just going to basically remove some excess solder. Okay, that's good. That's good. This feels good. Basically, I'm just, as soon as I see the wick move, I'm saying, all right, it's pulled away, whatever it's going to pull away. Also, be careful. I'm really doing this in a bad way. You really probably shouldn't hold it the way I'm holding it, but I don't know. As soon as I start feeling it to heat up, I sort of know that I'm probably holding it on for long enough, if that makes sense. All right, this one's pretty nasty. Might have been a little much. Okay, yeah, basically turned out to be the same. All right. Nope. Yeah, all right, we're just gonna leave that one. Okay. Guess I'm a little tired of seeing people drown parts in flux. Yeah, you know, the other thing too is, if you were here when I first started, first thing I did is wipe this down with alcohol. I think that's something else that people don't tend to do with their boards, is they don't clean them. And so especially in like repair, you really should clean the field, so to speak, before you start soldering. Flux is going to help, but you want to get rid of anything that could be a contaminant ahead of time. Love the through-hole version. Yeah, through-hole version is great. I'm really excited about the surface mount just because I think it's adorable. I mean, how often do we deal with components or electronics that are cute and adorable? All right, so resistors are done. They're not as great as I would like, but we're going to move on. So now we're getting into transistors, and there are two transistor types. There's an NPN and a PNP, and so we need to make sure we don't get those mixed up, otherwise it doesn't work. And so we'll start with the NPNs. And on these, there's two strips. Let's open up one of these. Now the good news is these are really difficult to put on wrong because they only fit one way. Come on, babe. All right. You have good technique. Oh, you're really polite. I'm actually really lousy at soldering. I would say I'm at least average. There's very few situations that I can't solder, but I would never call what I do good. One of my thoughts is one day I really would like to take like a crash course in the IPC soldering class, because I know there's a lot of things I do that aren't right that I would like to learn better, and I would just kind of like to know what is actual like legit solder technique, because I don't know. I taught myself when I was 12 years old, and the joke pictures of the stock images where people are holding the iron by the business end. I actually did that once when I was 12 years old, and I would like to say that I never did it again, except that I did. at least one other time. All right, so for these, the Q1 double check is a 3904, and I pulled out 3904s. Yep, okay. So how am I going to do this one? Yeah, clean my tip off again. What are you going to use the 555 for? Well, funny you should ask. It's a really simple counter circuit, but I've got a counter circuit that I built for a upcoming video. I still have the circuit built. It still has the 555 in it. If this one works, I'm just going to replace it, and we'll see how things work out. Okay. Blood sugar's definitely getting low. Oh, come on. Yeah, I did not want to use my finger. I don't want oils getting... All right, step one, make sure it's the right orientation. Step two, actually, you know what? Where did my other tools go? Let me try something. So I'm using these really fine tips. Let's try using something a little blunter to see if that has a better grip. Yeah. No. Yeah. All right. Solder. Okay, I think that's on. Now that's on. Did it? Wait, is it on? Nope. Nope. Boy, these are a little bit tougher. Do a couple things. First, let's get more solder on this joint. Okay. Now, let's get this transistor. Yeah, one thing you got to make sure, and I can see somebody making this mistake, it'd be really easy to solder these upside down, which obviously you don't want to do. All right, so let me try a totally different holding technique so that my hand's not as cramped. All right. Okay. Yeah, that's a lot better. I just wasn't holding them very well. Okay, it's on. I'm going to move it just a little. Not the best technique, but it works. Man, that is really not on there straight. Oh, that's not even close. Not the best idea because it could break the lead, which would be bad. I want to say this soldering iron tip might be too big for these parts. All right. I need my flashlight, so I'll just use my phone for the moment. Yeah, okay. That looks good. So right here, yeah, come on, there you go. Yeah, so there we go. One transistor soldered by hand. I think that's going to be the only one we do by hand. And part of the reason why is this iron that I'm using it's a beveled tip, and so it's kind of wide and flat, and it's making it difficult to get to the small pins of the transistor. I'm wondering if I used a sharper conical tip, if that might work better, but we're going to switch to something completely different anyway. I just wanted to try to get one transistor done with the soldering iron, and now we're going to switch over to using hot air. Let's see. I think it's against the law to build a timer circuit without including LED blinkies at one point. Agreed. Let's see. Holding the business in does not feel well. You know, the thing is, I remember every time I've burned myself on this part of the tip, I remember the feeling of being like electrically shocked. And yeah, I never liked that one. Live test the 555 circuit with a scope with different pulse widths and capacitors. Yeah, I would like to do that. It's not going to be tonight because I'm gonna be really hungry soon. But like I said, I've got one circuit where we should be able to just drop it in, and if it works, it'll work, and if it doesn't, well, then we'll figure out what we're doing. My opinion, the 555 is one of the most influential ICs in the last 40 years. Yeah, I would say influential, yes. I think the 555 and the 7805 are the two most important ICs that were ever made. You could make an argument for the 741 as well, but I think in terms of the 555 and the 7805, which is just a 5-volt regulator, but it enabled practically everything. You tear apart any piece of electronics from the 80s, and you will find those two chips somewhere in the design. Just digital electronics, I should say. Okay, enough stalling. Let's turn this iron off and get him out of the way. I'm going to pull this guy out and get this nice and good. And then I want to do number one, turn it on. That's not right. Number one, turn this on. Okay. Give that a minute to heat up. I don't think that's hot yet. Okay, I need to grab something to drink. So Sarlacc over on Twitch is asking about lead-free solder, like SAC 305, and I have played with it. I've got a couple of spools of lead-free. For what I would call professional work, I will use lead-free just to keep from uncontaminating a device. So, like, if it's a prototype or something, it's probably better just to not even risk messing it up. For home hobby use, I prefer to just use lead-free because lower temperatures, easier to work with, all those reasons. I think the concern about lead is valid. We should be worried about how much lead we're getting contaminated and getting into water supplies and things like that. But the amount of lead that we deal with is so low that it's kind of like, what's going on here? So for at home work, I'm just not quite there yet to use lead free. I just don't feel it. So okay. That really shakes the camera, doesn't it? All right, let's check this out. So I've got this low temperature paste. I just give this long speech about how I don't really care about lead, and this one's lead free. So anyway, I got this stuff off of Adafruit. It's this low temp stuff, and it melts around 140 degrees, which I think is going to be a good thing. So we're going to give it a try. So we'll try a couple of parts and see how it does. What is an LM317? LM317 is a variable output voltage regulator, which can also be configured as a constant current source. I've never done it, but I've thought about it. Okay, so let's see. So what we're going to try, let's just do one transistor first and see how well this stuff works. So we're going to try, let's see, Q1 to Q4 are all NPNs. So we're going to put a dab here. Not really coming out very well. Yeah, I don't think I'm going to like this. That's just way too much paste. But I'm going to give it a try, and if we don't like this, then I got another option. I wonder, actually. No, the tips aren't compatible. Is this a good kit for first go at surface mount soldering? So far, I would say yes. The thing that's going to be tough are these transistors. The resistors are all 1206, which is a really easy part to surface mount solder. But these transistors don't really have much in the way of a lead, and so I see them being a problem. This isn't going to work. I already see where this is going. Yeah. So if you didn't see it, the hot air just blew the transistor away. What do I have my? Looks like my larger tip too, so okay. This is not how Weller recommends to use this, but it's worked well for me, so we're just going to do it the way that I know it works and go from there. Yeah, great. All right, got that out of the way. Where did it go? Fortunately, I found it, but yeah, it blew right off. Okay, so let's clean this up. So some of the solder did start to reflow. Yeah, okay. So what we're going to do is go to plan B. The problem I think I'm having with this stuff is the tip applicator is just really, it's really blunt. What I normally use is this stuff from Chip Quick. What I'm worried about is I can already see it's starting to separate, so this might not even work very well. But we're going to give it a try. The first thing I want to do is expung, get a bunch of this stuff out of here. Okay. So the viscosity of this one is just so much better. Viscosity? Viscosity. Viscosity? Whatever. All right, so now we'll get this guy, purge this a little bit. Might need to clean that with alcohol still. Nope, awesome. So this is going to work much better. Okay, that looks like enough. So basically I'm just trying to get some of the stuff that's been stuck in the tip out because it's probably dried up a little bit. Need a circuit stencil. Yeah, actually I talked to EMSL about that, and they said that they plan to create a stencil file, but they're probably not going to offer a stencil for sale because they can't get a volume discount from anyone, which sort of makes sense because nobody really makes like a, nobody really needs more than one of a stencil. So there's not really like a, it's not like you can go and get like a big discount for ordering a bunch of them. But yeah, I'm going to hold off on the 741 kit for that stencil file because I do have a laser cutter and I can make stencils, and that would just be, that would actually go quite a bit better. Come on, get down there. Okay, so now let's try and grab this guy again. And I'm going to press it down, hoping that the solder paste will actually hold it. Okay. And now we will do this again. And I'll do my best so that you can see, but unfortunately, alright, flux looks like it's boiling away. Maybe. Maybe not. Uh-oh. Uh-oh. Uh-oh, Batman. There it goes. Bubble, bubble, bubble. See some silver happening. Silver ball, silver ball. Come on, one more. Silver ball. Surface tension. Just a little bit more. Come on, get the rest of it. And done. All right, so, ow. Dumbass. So if you compare Q1 to Q2, Q2 has a little bit more solder on it. Obviously, I put too much paste down, but it's straight. It looks, actually it doesn't look very good. Now I say that out loud. We're going to come back and do that one over. Shot. Wait a second. Yeah, that was bad. All right. You know what? I'm just going, let me just do my thing for a second, and let me see if I can, all right, let me do this. Let's really clean this. All right, 3 and 4 both Q, or yeah, 3904s. All right. And then I want to get this on here. Okay. I don't like how much is coming out. Yeah, I would really much rather have a stencil for this. Grab this. All right. Let's see how these work out. Smaller diameter needle. Yeah, that's the smallest one I have at the moment. All right, got one. And number 2 is going. Oh, I wish you guys could have seen that. The surface tension just pulled it right into place. Okay. Pro tip, I'm not going to touch it now. All right. Q3 isn't straight. No, it's not. It is definitely not. All right, 1, 2, 3, 4. Now we're going to go over to 14 through 18. So there's 14. Let me show you what I'm looking at. So, can I get that better? There we go. All right, so now we're doing 14 through 18. So that's 14, 15, 16, 14, 15, 16, 17, and 18. Okay. And 17's already got some of the other solder on it already. So first thing I want to do, let's make sure, I wonder if, and we'll come back and do 14 in a second. No, that doesn't usually help. All right, so 14, so basically we're doing this one, this one. Come on, just give me a little bit of paste. All right, I'll do 14 in a second because it's all by itself anyway. So we're going to put 18. And then in the future, if I do stuff like this, I promise to have music. I actually have a subscription to Pretzel Rocks, but I forgot to get that set up. Then oh goodness. So somebody was asking, is this a good kit, first surface mount kit? You know, it really is. The resistor so a question I should have asked is, are there any extra components included in the kit? Fortunately, this didn't go far, but I thought I lost this one. Nope, it's going to go upside down. Same with that one. Yep. Need more transistors. Pop this open. Good gosh. I am definitely getting tired. All right. I'm going to move this around. These wider, flatter blades are definitely working much better. Okay. All right. Does it come with extras in case they fly? You know, that was actually a question I had meant to ask when I picked up the kit, and I didn't, and now I'm wondering the same thing. Yeah, I'm gonna do a little more airflow this time. All right, so Q17 is starting to reflow. I'm probably favoring it a little bit because of the way I'm holding the iron or the hot air. I might have actually messed these up because this paste looks like it is dried out. Oh, okay. Well, 15 is done. Come on. All right, 16 just went. 18 is about to go. And 17 just got the last bit of it. All right. Whew. What fun. Does it come with extras? I caught that one. What temperature am I using? I'm using 400 degrees, and then I have the airflow set at 35%, which I'd have to go look in the manual to find out what the actual flow rate is, but I wanted it to be relatively low. The thing that I'm doing is I'm not using any kind of tip. This system is really meant to have tips on them, but I struggle with it just because I'm not good at using it yet. I've just found by keeping the tip wide open and just letting things take their time, I tend to have a little bit better results. So, like I said, excuse me. Like I said earlier, it's a system from Weller. They recommend not doing it the way I'm using it, but I found my results tend to work just a little bit better for me. So that's why I use it this way. All right, so I think 14 is upside down too, right? Yeah. All right, so let's throw him into place. And double check, is 25 is going to be a 3906. I don't want to get those mixed up. So we're just going to do this one real quick. I think at this point the board is preheated, so it might go a little bit faster than the other two did. Oh, I've got an idea. I know what I can do. Beautiful. Wow, that one was actually perfect. I got an idea. Because I think watching this stuff work with the hot air and how it reflows is really magical. As some of my friends know how I feel about that. So what I'm going to try, let's set something up here. Wow. Move these arms. I'm going to use a separate camera for when we do the next reflow step so that you can actually see how it works out. All right. I'll do that. And then this guy is going to do this. Turn this. Open him up. Nope. No way. Oh, this is going to be even more bouncy. That's going to be great. Okay, I'll just hold it. So we'll get that going on the next one. Okay, 14 through 18 are done. Now 20 through 22. I'm actually going to leave that out. Let's see if that gets a little bit better view. So I need 20, 21, 22, and 24, but not 23. So 20. Uh, 21, 22. So at this point, I'm just going for a smearing technique. I'm not trying to get like nice clean pads. I'm just basically, I'm going to let surface tension pull all the solder back together and clean up all my mistakes, which is probably what the other stuff would have worked well if I had done it that way. But that's okay. Okay, so this is going to go like this. Nope. But like when I do these things like with a stencil, oh, so nice. It just gives a place for the part to sit into and stick. But this isn't, I keep saying that, I mean, this isn't bad. I do think in terms of learning how to do like a surface mount board, one, if you don't have hot air, then definitely I would just say take your time in doing these transistors. It's entirely possible to do it with a soldering iron. The only real advantage of doing it the way I'm doing it is you get a little bit more consistent solder joints. I feel like they're a little more forgiving, but time-wise, it's probably about the same amount of time. I don't think the hot air approach is actually all that much faster. Now, if I was willing to put all of the parts down on the board at once and then reflow small sections of it at a time, the hot air would be faster. But I'm not willing to do that because there are 3904s and 3906s, and I do not want to sort out which is which later on. Okay, so instant changeo presto. We're going to do something really quick. I'm going to add scene, and I want the overhead only. And then we're going to bring this down to, oops. Bring this down to here. And let's see if it will focus on what we're doing. Okay, I'll kind of zoom this in so you can see two different ways of what's going on. All right, so now what I'm going to do is go to the camera, configure, focus. Don't think this is going to work any better. I feel like it's going to end. Okay, I'm going to try it anyway. This might be blurry. I can't, and if this doesn't work, I'm not going to do this for each one of these. But I'm hoping that I can get you a more like a view of what I see. We'll see how that works out. Come on. All right, so 21 and 22 just reflowed. 22 has just a little bit left over. And then 20 is being really stubborn. Wonder if it's connected to a ground or something. Or maybe there's just not enough paste. There you go. There you go. Didn't pull into... All right, so I don't know if you could actually see that. Yeah, it's not going to focus, is it? Okay. All right, I tried. I'll figure something out later on. There's got to be a way to make that work. I just don't know what it is. Yeah, I don't know what to do there. All right. Not sure how I feel about these. They didn't go as well as I would have liked. I might come back and redo 22 by hand. It doesn't look too hot. In fact, let's make a note of that right now. Okay. And then last is 24. So we're on camera. 24 is where? Oh, come on, really? Let's do this. Bring this around right here. Get my... Let's clean this up. What model hot air station? It's a Weller WXR3. It's a professional tool, or it has a professional price, I should say. It was actually given to me by Weller when I did a series of videos for them for Element 14 earlier this year. So what type of wipe am I using for cleaning? I'm just using alcohol. How do you say it? Isopropyl? I almost called it propylene because I'm used to propylene capacitors, polypropylene capacitors. But yeah, just regular old alcohol. If you do go to the store to buy alcohol to solder with, make sure you get at least 90%. Most of the stuff there is 70%, and it's just from a soldering perspective and cleaning up flux, that's pretty much useless. So yeah, you want at least 90. I was saying earlier, I was really excited. My local supermarket actually carries 99, which I don't know that I've seen that in a store. I probably have, but just didn't notice. Usually I get 91%, so I gladly picked that up. We're gonna try something just a little bit different. So I'm doing this transistor right here. Oh, damn it. Okay. Heat up, heat up, heat up, heat up, heat up, heat up. By the way, I can tell in the camera, it looks like where I'm pointing the hot air is nowhere near the transistor, but it's just a parallax that's going on. I mean, I can see it. And so we can see the solder starting to like kind of ball up, little tiny balls, little breaks. It looks like it's like a dirty sand. And so I think all of the flux is boiled off. So we'd be at the preheat soak. We're sort of in the soak. We're ramping up to reflow at this point. And what we'll see happen almost all of a sudden is all of the gray will start to turn silver. There it goes. And so it silvers up, turns into quick joints, balls up, and then if the transistor's off on the pads, we'll actually even see the transistor move a little bit. That's it. Now, for a single component, you know, that's actually probably slower than soldering it with a regular iron. But like you might have seen when I did these others, I was able to do 2 or 3 at the same... What? Did you see this? This transistor just came off. Well, that makes me want to do this now. Unreal. I've never had that happen before. So let's clean that up. Gonna need the other soldering iron. Nope, 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 nope. You stay at 400. Let's get this one turned back on. Move this out of the way. For trickier package sizes, I've attempted... Oh, far trickier. Yeah. This is a SOT23, which isn't terrible. I actually have more luck with things like a QFN, just because you just basically just heat the whole area and it will eventually reflow. This one's a little trickier because you have the 3 leads, and so they're not... You don't get as much surface area for the part while you're waiting for it to make contact. All right, so we're at... Why did it turn off? Turn on, heat up, clean it. Now we can go into here. Okay, those pads are much cleaner now. Now I'll grab some things. Yeah, for the cleaning cloth, I'm just using paper towel. I used to use wet wipes until I realized that they were only in the order of they were actually 70% alcohol, and so I just was like, okay, that's not going to work well enough. All right, put some paste there. Put our troublesome part back on the pads. Okay, surface tension is holding it. I'll try to do the same thing. So the one that I'm soldering this time is number 20, which is right here. And we will go hot air. Really small circles. Q-tips will work great for cleaning. I'm not a big fan of using them for putting the paste though, because you might end up with like cotton and stuff, cotton fibers getting stuck, which I guess for cleaning, yeah, actually, good point. Because in the next round, we're definitely going to need that. Okay, reflow. It didn't move though. That bothers me. Not sure about that. Which one? Q21 is looking wet. Yeah, I think it. Yeah, that area got hot. I think 21 and 22. I'm gonna have to go 21 and 22. These up here. I'm gonna hit those with the regular iron when I'm done. I think this is acting as a baffle or something. It's not allowing the air to flow around those. Yeah. Okay. I think that's the last one. So somebody asked earlier, are there extras? Well, it turns out there is one extra transistor, or I missed one. Let's actually check that. So 5 through 13. So 5, 6, 7. 5, 6, 7, 8. I don't see 9. 9, 10, 11, 12, 13. Okay, so these are all PNPs. What does it say? 19. So Q19. There's 2 there. And then 23 and 25. Okay, looking good. How do we want to do this? Let's go ahead and pull this off a little bit. All right. We are going to take the suggestion that I was just given. Get a couple of Q-tips. And then throw some alcohol onto those. And let's clean up this area. This area. Go ahead and do all this. And I'm going to, as I get to these others, I'm going to clean them again. But why not? Okay. Okay. Might not need those. Cool. I could use flux. I'll show you what happens. I'm not a huge fan of using flux with solder paste for soldering. For desoldering, yeah, I'd be throwing flux down left and right. But here's what happens at least when I do it, and you know, the internet's really good about telling me everything I do wrong. So if we throw this flux onto, say, Q8, all right, and then I'm going to actually spread it with a clean tip instead of just leaving it bubbled up, because it seems, well, I don't know. Now I'm just, actually, I've never done it that way. I've never spread it out, and that makes a huge difference. Okay, well, today I learned. Thanks, M-Ice. Because you said something, I decided to go ahead and try it. Yeah, Q20 is barely making contact. Yeah, all 3 of these, I'm not going to worry about them right now. They're all in bad shape. Because you said something, I tried something new. Normally when I put the flux down, I just leave it in as a bubble, and that doesn't normally work, and now I realize why. Actually spreading it out really seemed to help that time. Where are we at? 8 o'clock. All right. So now these are all upside down. I want my other ones. Okay. Transistor 1. Number 6. Get on there. Number 7. And number 8. Okay. Beautiful. Yeah, those went down really well. We will see how well, Flux does multiple things. Number one, its primary purpose is to latch onto and boil away contaminants, or at least get them to move out of the way of the solder. The other thing, and this is probably a little less understood about it, is it's slightly acidic, and so it does actually slightly etch the metal surfaces, and the idea is that way solder can wick into those etched areas, and so it makes for a better joint for 2 reasons. It cleans, and then it also does a little bit of etching process. Yeah, okay. That worked a heck of a lot better. I feel very silly for not doing that sooner. Okay, let's try that again. So in the past, what I had done, and that's why I just realized as I was kind of going through this, it was kind of stupid, is I would just basically leave the flux on there as a bubble, and it's just too much. But if I do something like this, then it actually gives the paste something to stick to. So maybe it does 3 things. Ooh, come on. Okay. Beautiful. All right. Let's do those 2. Where's this at? And do this one. All right, they're both on there. And then we will do it like this again, so you guys can maybe see some of the magic happening. Which one's going to go first? Q13 on the left or Q12 on the right? Q13 has a lot less solder paste. I got a little liberal on the 12. Lost it. Shit. Okay, so that one snapped right into place. There's no way 12 is going to. All right. Now, let's just start over. Okay, let's get a little bit of alcohol. Okay. A little bit of solder paste, flux. Let's kind of break up that bubble. Get our paste into place. Doesn't look like it's enough. Okay. And then, did I pull it out yet? Yeah, let's use... this transistor. Okay. Not going to tilt it this time just because I don't want it to fall off again. Yeah, I think in regards to just pouring flux all over, for high pin density parts, it definitely makes more sense. For something like this, probably not as much. Yeah, that looks hella good. Totally saved it. Okay, what do we got left? 19, 19, 23, and 20. Okay, let's get 19 and 19. Should be kind of easy. They're right next to each other. Wait, 9? The hell is 9? I'm sorry, what the heck was 9? Okay, 9 is another... Yeah, okay, we got 3 to do. I don't like doing... I'm going to try something different this time. I'm only going to concentrate on one at a time. I think I'm trying to spread out the heat too much for the kind of general area of what I'm doing. So we'll prep all 3, but then we'll do one at a time. Okay. So we need 1, 2, 3, 4, 5. And we have 1, 2, 3, 4, 5. Yeah, we've got quite a few. Oh no. We need 5. Oh, we might be a little. I think there's only 1 extra. Q25 is a complete sub-circuit. Yeah, I'm going to do 23 and 25 on their own. What I'm going to do though is just like this. I'm going to prep them both so I can do them back to back. But I don't like prepping more than what I'm working on because like if you have to redo it or clean it or whatever, it makes more of a mess. Are you kidding? I keep using the really thin tweezers. They have a really sharp tip, and oh, nope, it's upside down. Okay. Is it upside down again? No. Okay. This is your home. You stay at your home. You stay right there. Okay? I didn't say move, I said stay. If you're a good transistor, then I'll give you voltage. Next on At Ohms Live, James builds his own pick-and-place machine. Okay. Someone on here said to put a variable resistor on the board instead of set value resistors. Oh. Well, I think variable resistor for whatever you hook it up to makes sense. Why would you... I mean, the resistor values that are inside the IC are set for a specific reason. Like R8 and R9 are a voltage divider for the comparator circuit. Okay, 9 is reflowed. Nice and clean. We'll go to 19B and reflow. 19A, ooh, fail. Shit. Shoot, I mean. Okay. So 9 reflowed and then came off immediately. That's not good. So, all right, let's do this. I'm going to take a quick break. I'm going to go grab a snack, and then I'm going to come back and finish up this since we just had the third, probably third major mistake. So I just want to take 5 minutes, and I'll be right back. In chat, let me know. Why don't you talk about what is since I'm taking a break, what's a case where you're building a circuit or working on a circuit and taking a break actually helped? Tell a story. I'll be right back. All right, so we're at about step 5, which is install the 3906s. And I think we got half of them on because so I've got to redo 9. 1, 2, 3, 4, 5, 6. A little more. Ah, thank you, Wesley. You're so kind. So we got those, and then we got to do the nuts, and then put the whole thing together. I sort of have a rule: when multiple mistakes happen, it's probably time to take a break. I think what I'm going to do is say, I'm going to clean up a few things, and then I'm going to put this down for now and pick this up probably tomorrow afternoon, maybe even in the morning, because once I'm done soldering, I'm going to want to hook it up and see if it works. And if I finish right now, I'm going to skip that step. I already know myself well enough. So I'm going to wrap up at the moment because I need to clean up and then do some things. And then, like I said, tomorrow, Sunday at the latest, I'm going to come back and finish this. So far, I'm really enjoying putting the kit together. I'm really excited to see this thing. I think, as I said earlier, I think this board is just absolutely adorable. Eric did a really great job. If you don't know who Eric is, go find Tube Time US. There's 2 on Twitter, so you want Tube Time US. He's the one behind this board. He also did the Monster 6502, which is a fantastic project as well. So for now, I'm gonna wrap up a few things with chat, and then, like I said, clean up. But I'm gonna take a break and come back. So this is a great time. If you're not subscribed, whether you're watching on Twitch, YouTube, or Facebook, now is a great time to subscribe so that you know when I come back to work on this again. I want to thank absolutely everybody for coming by and asking lots of questions. I saw lots of great soldering discussions. I'm really excited to see this thing work. And like I said, we'll come back to it and get this thing finished up in another day or so. My name is James, and I'm the Bald Engineer. Thanks for stopping by. I don't know where the button.